Okay, so application problems with quadratic formulas, Algebra 2, our last lesson in this unit. Here's our learning target. I can use the quadratic formula. And again, that's opposite b plus or minus b squared minus 4ac all over 2a to solve word problems. We just mentioned a moment ago that anytime we throw an object, it follows the path of a parabola. It would follow the equation, in other words, of ax squared plus bx plus c equals some function, equals really our height. And that's what we're seeing right here for example 1. You don't even have to, make the equation. They're always going to give it to you. But a ball is thrown from an initial height of 2 meters. So this ball is, starting at 2 meters. You can see the 2's actually here in the equation. It's thrown with an initial upward velocity of 13 meters per second. That's right here, the 13t. And that says the ball's height h is in meters. After t seconds, here is what we have. So first of all, notice that instead of having an x, we have a t. That's because we're going to have our height depending on time. So, we just have to realize that instead of solving for x, we're really solving for t. But here's all you have to do for part A. It says find all the values of t for which the ball's height is 7. So look, here's all you got to do. You have your equation right here. You want the height to be 7. And guys, we're going to go ahead and get 0 on a side. Now, it's okay to have 0 on the left side. And we're going to do that here. We can minus a 7. And what do we get? Negative 5 plus 13t minus 5t squared. I usually put a little curl on the t to help us out. And then tell you what, I'm going to write this in something called descending order. I'm going to put my squared term first, negative 5t squared. Here's my plus 13t. Then I'll have my minus 5. You might think, well, why are you doing that? Well, for a quadratic equation, now instead of having an x, we have a t, but it's the same thing. Our a is what is in front of x squared, or in this case, it'll be what's in front of t squared. Our b is what is in front of our x or our t, and our c is our constant. So looking at this equation right here that we had last drawn in, what is our a? What do you think? A would have to be negative 5. You got it. Guess what B is? 13. And guess what C is? Negative 5. Now, here's the cool thing. You've already done this type of stuff before. We're going to try to answer to the nearest hundredth. We're going to let the calculator do all the busy work for us, okay? So I'm going to take negative 5, hit the store button. It's right by the 1. Then I'm going to go alpha A. Then I'm going to go 13. I'm going to store that in for alpha B. I'll take negative 5. I'm going to store that in for alpha C. And then hopefully you remember what we were doing just this last lesson. What did we do then? We just type out the quadratic formula. We type out the quadratic formula. We go alpha y equals, and I'm going to go opposite, hit that negative, alpha b plus, then we'll go square root of alpha b squared minus 4 alpha a alpha c. We're going to come down here and we're going to say 2 alpha a. And this is going to give me one of my answers. And evidently, it's going to be going to the nearest 100 0.47 seconds, evidently. So we would say t is equal to 0.47 seconds. Now, of course, somebody could quickly point out that there is a second answer. It might not make physical sense, though, in this situation. Remember, we can always do second enter and change the plus to a minus. Now, when we do that, you'll get 2.13. Here there are two answers. There are two answers in this scenario. 2.13 seconds also. So what would we write in Alex? We have to separate that by a comma. 0.47 seconds and 2.13 seconds. So here's physically what's happening. The ball is being launched from, what was it? I guess 2 meters, right? And eventually it's going to come up here at 7. It's going to be coming back down right here at 7 too. So there are 2 times when that's going to happen. Okay? The last problem that we're going to be looking at, and it's very much the same scenario. I'm going to recopy this equation. 2 plus 13t minus 5t squared. It says, how long after the ball is thrown does it hit the ground? Well, let's think about this for a second. You'd say, let's see, hitting the ground means that your height is what? 0. Very good. So you set 0 right here. Hey, look at this. We can real quickly just solve this thing. Now, guess what? Your A is going to be, what do you think? -5, right? Your A is right here. What's your B? 13. Your C is 2. Only one of those changed. Only one of those changed because what am I getting at? Up above, your A was -5, 3, and your B was 13, your C was -5. Here, your A is -5, your B is 13, but your C is 2. Now, you could restore everything, but do you see how you don't have to change A or B? Yeah. Right? A and B are the same. So you just have to change one thing. You got to change your C. So tell you what, I'm going to go to store alpha C. Now my A is still locked in at -5. My B is locked in at 13. I just have to get the quadratic formula typed out. Now, do I need to retype it, do you think? No. Look at this. Second enter, and look at that. I've just pulled out the one with the minus. That's the last thing I typed out. Evidently, that's going to be 2.74 seconds, right? 2.75 seconds. Now, you might wonder about the other situation with the plus, and we can go ahead and do that. So if we just bring this thing up, change that to a plus, that's the negative. That doesn't make sense. You don't put that one down. You can't have at negative time the ball was on the ground. That doesn't make any sense. So usually that's what you're going to see for this last type of a problem. I guess what I want to show you, though, is ultimately what we did with lesson 5.19, solving with the calculator, is exactly what we're doing here. So we're going to get started right now.